Hey, we were supposed to launch on what was it, May 20?
April 27th.
Yeah, April 27th. Yeah, I couldn't do that, so now we have to do it on the 18th of May.
We did that because of the jet stream. We were originally going to launch from right here near Moscow. The stream was going to carry the balloon all the way out here, where this would be where the balloon would originally have bursted, and then the jet stream would have carried it like farther, and it would have landed out here, which would have been too far to go get. So now we're going to have to do it on the May 18th, hoping that it will be less far away. So this is the jet stream.
And the jet stream is represented by blue arrows.
Hello, I'm Jared, and for the weather balloon we're going to be sending up this little marshmallow guy. Now what we're going to do is once it gets up 100,000 feet is see if the air pressure is either going to shrink the marshmallow man or expand it for the whole entire Ziploc bag and explode.
Hi, this is our CO2 and ozone detector board that we're going to be putting up in a weather balloon eventually.
Get him, Nick.
Alright, so it's going to be powered by a 9-volt battery, and the data is being collected with an ATtiny85 microcontroller. We have an ozone sensor and a CO2 sensor. The CO2 sensor outputs a voltage between 30 and 50 millivolts, while the ozone sensor is a variable resistor between 50,000 and 500,000 ohms. So basically, this is the board. We've got a 10-pin header, which allows us to program the chip and pull the data off of it. The chip runs off a 5-volt regulator, and the two sensors have a heating module which allows them to work that runs off a 6-volt regulator. So we've got a power switch to allow you to turn it off, a button hooked up to the microcontroller which allows you to stop and start the data collection, and an LED which lets you know that the power is hooked up, and another LED that will blink which lets you know that it is in data acquisition mode. Alright, so to calibrate our ozone sensor, we have arranged with a NASA person to use the data from their already calibrated ozone sensor, and we'll take data points in the morning and afternoon, which should change by about 10 parts per million, and that will allow us to see if our sensor is actually working the way it should.
What do you think is going to happen to the Marshmallow Man when it's 100,000 feet up?
I think it's going to expand unless it freezes first.